For the iron spectroscopy lab, we use a scale sample. What does scale consist of? Calcium salts, magnesium salts, particularly carbonates, and the major corrosion product of the steel pipes, which is the rust, the iron oxide. And this scale sample here with the iron oxide in it has been finely ground, so it's easier to react with the hydrochloric acid to dissolve. First, we need to determine the mass of our sample, and therefore we go to an analytical balance. We turn it on, tare it to start with exactly 0 grams, and then place the container with our sample on the balance. We record the mass and then transfer all the substance into our reaction container, a 150 milliliter glass beaker, and then the empty container is weighed and the exact mass is recorded. The difference between these two masses is of course the mass of our sample. In the next step, we want to dissolve the salts of the scale. For that we use 10% hydrochloric acid. When the hydrochloric acid reacts with that scale sample, it is A, an exothermic reaction, and B, it produces carbon dioxide gas from the reaction with carbonates. This gas, if it was formed too fast, could cause splattering of that hot acid mixture, and therefore we add the acid with a glass pipette in really small amounts. And I hope you can see on these images how some bubbling has occurred as we added the acid. After we have added about 50 milliliters of 10% HCl, we end up with a heterogeneous mixture where some of the scale is suspended now, some of it's dissolved, and some of it is still solid. So the next step involves heating this suspension to complete the dissolution process. To heat it, we place it on a hot plate in a fume hood, add a watch glass on top in case there's any splattering occurring, because we want to heat it so that it lightly boils. And as you can see here, some condensation droplets around the side of the beaker and the solution that is forming turning yellow. Now the scale sample has been digested, means it has completely dissolved in the acid. And the next step involves transferring this sample into a 100 milliliter volumetric flask. This has to occur quantitatively, and we therefore rinse the beaker with plenty of distilled water. We even rinse the funnel with plenty of distilled water to ensure all of the sample ends up in the volumetric flask. Because this solution is still warm, we need to cool it down to 20 degrees so that the calibration line in the neck of the volumetric flask shows the actual volume of the content, because hot solutions, hot liquids, would expand the glass. Now we fill the volumetric flask with distilled water in small increments and always swirling and mixing in between so that the density stays homogeneous. The last drops to reach the calibration line are added with a glass pipette, and we are finished when the lower part, the bottom of the meniscus, is in line with the calibration line in the neck of the volumetric flask. Here you can see we still needed 1 or 2 drops to reach that situation. When the volumetric flask is filled like this, it's a bit difficult to swirl it, so we added some parafilm and inverted the flask to ensure perfect mixing. Now all of our digested sample is in the 100 milliliter volumetric flask, but it is still too concentrated for the spectroscopy, so we dilute it by factor 20, and for that we pipette 5 milliliters of this solution into another 100 milliliter volumetric flask. After pouring some sample into a beaker, A volumetric pipette is placed into that beaker. A suction bulb is squeezed and then placed on top of the pipette. And releasing that suction bulb slowly pushes some liquid into the glass pipette. When the liquid is above the calibration line of the pipette, the tip of the pipette is resting on the bottom of the glass container and the suction bulb is replaced by the index finger. Releasing the pressure on that index finger will then allow to release the liquid until the level of liquid inside the volumetric pipette is in line with the calibration line of the pipette, which means again the lower meniscus of that liquid has to be in line with the calibration line. Now we can transfer these 5 milliliters into a new 100 milliliter volumetric flask, and we don't have to worry about the last drop that stays in the tip of that pipette because they are calibrated to deliver, so the last drop in that tip is already accounted for and we don't have to shake or blow it out to deliver 5.00 milliliters. Finally, we fill up to 100 milliliters, again first with a water bottle and then with a glass pipette, intermittently swirling and mixing. And in the end of the day, we want, again, the lower meniscus in that neck to be in line with the calibration mark on that neck.